Hello students, I am Dr. Sanjeev Ponia. In last lecture, we discussed about three-dimensional transformation in computer graphics. In first part of unit 2, we discussed about 2D transformations in which we discuss the difference between geometrical and coordinate transformation. Then we discussed that how we can represent an object in the form of matrix and how we can represent that in homogeneous coordinates. After this, we discuss about the basic transformation technique on two-dimensional, that is translation, scaling, rotation, reflection, and shearing. And in the last, we discuss about composite transformation. The second topic we discussed in second unit, that was window to viewport transformation. And in last lecture, we start three-dimensional transformation. In this, we discuss that how we can represent a 3D object in the coordinate systems using matrix form. And from the transformation properties, we discuss two properties. First one is translation, second is scaling. In translation, we discuss that moving an object from one place to another place, whereas size of the object is fixed. And in case of scaling, size of the object is going to change as well as position of the object is also changing with respect to earlier coordinate or old coordinate. Now we will discuss about the 3D rotation in today's lecture. So rotation of an object with an angle, for an example, any angle in a three-dimensional point. Let me draw. Suppose this is a 3D system, 3D coordinate system, and we have this object. We have this 3D object. Now we want to rotate this object. We want to rotate this object. Then this is x-axis, this is y-axis, and this is z-axis, as we know very well. So there can be three cases. Either I am going to rotate it with respect to x-axis. So when I am rotating it with respect to x-axis, then it will be between coordinates between axis x and z. When it was belong to, or when it was in between axis x and y, and we are rotating the object with respect to x-axis, then the new coordinates of the object will be between x and z direction axis. And there can be another case that we can rotate this object with respect to x-axis. In that case, this object will be over here, that is between y and z axis. And in third case, we can rotate this object with respect to z axis. This is our z axis. This is our z axis, so we can rotate this with respect to z axis. So there are three possibilities for that. That is rotation with respect to x-axis, rotation with respect to y-axis, and rotation with respect to z-axis. Suppose we have a object, suppose this is a object, this is a point A of 3D object. It means it has three coordinates x, y, and z. Suppose earlier coordinate are x0, this x old, y old, and z old. And we are rotating this object with an angle phi. We are rotating this object with an angle phi. As we discussed in two-dimensional rotation also, and we saw that what's the matrix represent or how we can find out the coordinates of new object after the rotation with a angle phi. So for an example, the new coordinates after the rotation is x new, y new, and z new. Whereas the rotation angle is theta and initial angle of object O with respect to in x y means in 2D we discuss this that suppose this is x axis, this is y axis, then we saw if this is a point, this is a 2D object, then there will be the point x old and y old, y old, and in starting it is making a angle phi with respect to point O, that is origin. So this is the angle phi, and we are rotating this object with an angle theta, with an angle theta from here to here. This angle is theta. In the same way, it is given over here that we have three-dimensional. So if this is a three-dimensional means a dimension z will also be over here and a 1 point. Let me change the color to change it into the three-dimensional. So third dimensional will be over here as we discussed, and there is one more point. Instead of x and y, there will be z0 also. Z0 also. Now, this is the same case that earlier it was at phi angle. Earlier it was at phi angle, and we are rotating this object, rotating this 3D object with an angle theta. So these things are given to us and we have to find the new coordinates of the object after the rotation. So this is our motto to find out the new coordinates. So as I told that there are three possible ways that we can rotate with respect to x-axis, with y-axis, or with z-axis. So in all the three cases, the values of the matrix will be different, or the way in which we will calculate the values of new coordinates, then there is different way for that. So when we are rotating the object, with respect to x-axis. In that case, the new value of the x coordinate will be same. So there is one thing clear from here, that in x-axis the x coordinate value will be same, in y-axis the y coordinate value will be same, and in z-axis the coordinate values of z old and z new will be same. The values of y new and z new depends on the angle how much we are rotating with. So you can see from here that these are the old one, y old and y old, z old and z old. So when we are going to find out the value of y new, then we are doing y odd into cos x. This is multiplied by cos x minus z old into sine theta. Same in the case of when we have to find out the values of z new point, then in that case this is y old into sine theta plus z old into cos theta. And if you will see this thing clearly, then this is the same thing we were doing in the 2D also. In 2D, we were writing cos theta minus sine theta minus sine theta. This is sine theta. Sine theta. And in the next row, it was sine theta and cos theta respectively. If you are remember the things, then this was the rotation matrix in 2D, and it was when we are rotating this in anti-clockwise direction. When we are rotating the object in clockwise direction, then in that case we have to take minus theta instead of theta. Then it will be cos minus theta means cos theta, so it will be same cos theta. This is sine minus theta is minus sine theta, so now it will be sine theta plus sine theta, and this will be over here. The values of sine theta is going to be changed from sine theta to minus sine theta, and cos minus theta is equals to cos theta. So we studied this in 2D dimension. So over here also this is the same thing. This is the same matrix we are going to study. You can see from here. Let me erase it first so that it will be more clear. Over here you can see that when we are rotating with respect to x-axis, then the value of x is same. This is x multiplied by x old, so this is x new equals to x old, and we are changing the value of y and z, and the matrix for that is same 2D matrix, but keep in the mind that we are using this with respect to y and with respect to z only. With respect to z only. Here also in y and in z. So we are not using in the case of x. In the next phase, when we will rotate it with respect to y-axis, then it will not be in y. So let us see for the y rotation also. So this is the new values for the y rotation with respect to y-axis. So you can see over here that value of y new is equals to y old, means we are not using the 2D matrix, the values of 2D matrix in y. You can see from here also and from here also. So to find the value of y new, we have to multiply this row with this column. So when we are multiplying 0 with x old, so this is 0. 1 with y old, so only we are getting y new equals to y old. All other values are 0. Same, we are getting the matrix that is cos theta, sin theta, minus sin theta and cos theta. Same in the case of z-axis, means when we will rotate this object with respect to z-axis, the values of z coordinate remains the same. So here you can see that the angle theta does not have any effect on z coordinate. Over here also you can see that it is not have any effect on z coordinate. So when I want to find the value of z new, in that case this is this row multiplied by this column. So this is 0 multiplied by 0, 0 multiplied by 0. This is 1. So 1 is going to be multiplied by z old. And this is 0. This is 1. So this is also 0. So in this case, z new is equals to z old. And you can see from here that this is for the x, this is for the y, this is for the x, and this is for the y. So same matrix, same rotation matrix we are writing on in x and y, and you can see from here that to calculate the values of x coordinate, the new values of x and y coordinate, we have to use the 2D matrix values, that is cos theta minus sin theta and sin theta. This is sin theta and cos theta. So these are the three matrices. We can use matrices or we can find out the values using these equations only. So now we will see an example based on 3D rotation. So this is an example. We will try to solve this example based on the rotation with respect to x, y, and z axis with an given angle. So given a homogeneous point 1, 2, and 3, means values of x old is 1, y old This is y old is 2 and z old is 3. These three values are given till now. We have to rotate means apply a rotation of 90 degree. So theta is equals to 90 degree. So this is the value given for theta towards x-axis, y-axis and z-axis. Means this object is going to be rotate with respect to x, y and z with same angle, that is 90 degree. And we have to find out the coordinates of x new, y new and z new. So these are the things given to us, that is x old, y old and z old. Those are 1, 2 and 3 respectively, and rotation angle, that is theta is 90 degree towards x, y and z axis. So now we will apply the same formulas. We will apply these formulas for x-axis. We will try to find out the values for three values, then for y-axis and then for z-axis. So first we will find the values with respect to x rotation. So suppose new coordinates are x new, y new and z new respectively. Then applying the rotation equation for x axis, then x new equals to y new, x new equals to x old, that is 1, it's given. And when we have to find out the values of y new coordinate, then it is y old multiplied by cos theta minus z old multiplied by sin theta. So value of y old is 2 multiplied by cos theta, theta is 90, so 2 into cos 90 minus value of z old is 3, this is sin theta means sin 90. The value of cos 90 is 0, cos 90 is 0 and value of sin 90 is 1. So this is 2 multiplied by 0, that is 0, and 3 multiplied by 1 is 3, that is minus 3. So the value of y coordinate, latest or new y coordinate is minus 3. Now we will try to find out the value of z coordinate. So z new equals to y old into sin theta plus z old into cos theta. So y old is equals to 2, z old equals to 3. We used in the above equation also. Sin theta means sin 90 and cos theta means cos 90. Sin 90 is 1. This is equals to 1. So 2 multiplied by 1 is 2 and cos 90 is 0. So this is 1 into 0 is 0. So this is equals to 2. So when we are rotating this object with respect to x-axis with an angle 90 degree, then final values are 1, x new equals to 1, y new equals to minus 3 and z new means new coordinate of z is 2. So after rotating the object with respect to x-axis, the final values are 1 minus 3 and 2. Now we will try to find out the values of f, y and z new coordinates when we will rotate this with respect to y axis by using these three equations. So now we will find this with respect to y axis rotation. So the, suppose the values of f, y and z coordinates are x new, y new and z new. So when we are rotating with y-axis with respect to y-axis, then value of y new equals to value of y old, that is 2. And we have to find out the value of x new. So this is z old multiplied by sine theta plus x old multiplied by cos theta. So z old is equals to 3 sine theta, that is sine 90, and this is x old is 1, this is cos 90. The value of sine 90 is 1, so this is 3 multiplied by 1 is 3, and cos 90 is 0, so this is 1 multiplied by 0 is 0. So final values of x coordinate is 3. Now the final value of, that is new value of z coordinate is y old multiplied by cos theta minus x old multiplied by sin theta. That is y old equals to 2 cos theta. Theta is 90 degrees, so this is cos 90. Then x old is 1 and sine theta. Theta is 90, so this is sine 90. The values of cos 90 is 0. So this is 2 multiplied by 0 is 0 and 1 multiplied by value of sine 90 is 1. So this is 1. 1 multiplied by 1 is 1. So the final value is minus 1. So the values of new coordinates 3, 2 and minus 1 in x, y and z. Now we will try to find out the new coordinates of the object when we will rotate it with respect to z axis using these three equations. So now to find out the new values when we rotate the object with respect to z rotation, we discuss over there that the value of z new equals to value of z old, that is 3. To find out the values of x new and y new coordinate, these are the equations. So x old multiplied by cos theta minus y old multiplied by sin theta, and x old equals to 1, x old equals to 1 cos 90, cos 90 as theta is equals to 90. This is y old is 2 and this is sin theta, that is sin 90. Cos 90 is 0, cos 90 is 0, so 1 multiplied by 0 is 0 and sin 90 is 1. So when we multiplied 2 by 1, so this is 2 means it is 2. So final value is minus 2. When we will find the new values of y coordinate, then this is x old multiplied by sin theta plus y old multiplied by cos theta. The values of x old is 1 multiplied by sin theta. Theta is 90, so this is sin 90. Value of y old is 2 and cos theta, that is cos 90. Sin 90 is equals to 1. This is equals to 1. So 1 multiplied by 1 is 1. And this is 2 multiplied by cos 90. Cos 90 is equals to 0. So 2 into 0 is 0. So this is 1 plus 0, that is 1. So when we rotate the object with respect to z-axis, then final values of f, y and z coordinates are -2, 1 and 3. So these are the final values of object with respect to the with respect to the rotation in different axes. So in the rotation, we discuss that when an object is going to be rotated, then it can be rotated in three ways, that is with respect to x-axis, then with respect to y-axis, and with respect to z-axis. A rotation angle will be given to us when we will rotate it with respect to x-axis, then value of x will be same, value of x will be same. When we will rotate it with respect to y-axis, then value of y will be same. And when we will rotate it with respect to z-axis, then the values of z coordinate will remain same. And we discuss one example also based on this. So I think it will be more clear after the example. In exam, they will ask about one axis rotation only. Either they will ask for the rotation in x-axis, y-axis, or for z-axis only. It happens rarely that they ask for all the rotations. So in next class, we will discuss about reflection. So thanks a lot. Thanks for your patience.